Hello friends, this is Urmila, and in this video we are going to see some examples on logic gates. Let us see the first example. The question is like this: draw logic diagram for given Boolean expression and also write its truth table. You are given an equation and you have to construct a logic diagram for this equation. How to solve for this? Just observe the operations in the given equation. What are the operations here? For this term, there is an inversion operation. This is an OR operation. So you will need a NOT gate for this inversion and you will need OR gate to form this bracket. For the another bracket also you will need one NOT gate and an OR gate, and then there is multiplication of these two brackets. So you will need NOT gate. So let us start. There are two inputs A and B to this circuit and there is output Y. So let us have input A. This is input A and input B. To produce first bracket, you need A bar. So here you have to add NOT gate. It will produce A bar, and then B is taken directly. Here there is OR operation, so let us add OR gate. This OR gate will produce A bar plus B. Inputs to this OR gate are A bar and B. So it will produce A bar plus B. For second bracket, for this bracket you need A directly and B inverted. So let us take A directly and let us take B and invert it. So here you have to add NOT gate. And then these two inputs are given to an OR gate because you need OR operation here. So let us add OR gate. This OR gate will produce A plus B bar. So you have got these two terms. The first term A bar plus B and the second term A plus B bar. Now there is multiplication of these two brackets. That means you need an AND gate. So this input is given to AND gate and this A plus B bar is also given to AND gate, and this AND gate will produce Y, which is multiplication of these two terms. So in this way you have got the logic diagram for given Boolean expression. What we have done, we have just observed the operations in the equation and accordingly the gates for these operations are placed in the circuit. Now how to construct a truth table? Now here there are two inputs A and B, and hence the two columns for inputs are there. Then the different terms in the equation, you need A bar plus B, so let us calculate A bar also. You need A plus B bar, so let us calculate B bar also, and then we'll get Y. Now there are two inputs and hence there are four combinations of inputs, 2 raised to 2, that means four combinations of inputs. And what are the combinations? 0 0, 0 1, then 1 0 and 1 1. For the first combination, A is 0, so A bar 1, B is 0, so B bar 1, A bar plus B, A bar plus B, 1 plus 0 is 1, A plus B bar 1, and product of these two, 1 into 1, 1. Next A0, so A bar 1, B bar 0, A bar plus B, A bar plus B, 1 plus 0, 1, A plus B bar, A0, B bar 0, so 0 plus 0, 0 and product of these two is 0. Next, A bar will be 0, B bar will be 1, A bar plus B, 0 plus 0 will be 0, then A plus B bar, 1 plus 1, 1, and product of these two will be 0. Next, A bar will be 0, B bar 0, then A bar plus B 1, A plus B bar 1, and product of these two 1. In this way, we have constructed the truth table for given logic equation. Let us see one more example on constructing a logic circuit. What is the question? Draw a logic diagram for given Boolean expression. Again, observe the operations in the equation. Here, the first bracket is OR operation and then its inversion. That means it is NOR operation. So, you can put NOR gate for this term, and here there is dot, that means AND operator. So, here you need AND gate, and AND operation of A bar and B bar is done. That means you need a NOT gate for this term and one more NOT gate for this term, and then the product is the two terms are multiplied, right? And finally, there is inversion of the product of these two brackets. So, start from the inner side of your equation, right? That means for the first term, say for this bracket you need a NOR gate. There are two inputs A and B, so let us have two inputs, input A, input B. For the first term you need NOR gate, so let us put a NOR gate here, NOR gate. So, A is given to this NOR gate and B is also given to this NOR gate. NOR gate will produce A plus B bar, that means this bracket. Next, you need A bar and B bar for this bracket. So, take this A and apply an inversion to that A input. So, this will produce A bar. Next, take this another input B and pass this also through a NOT gate. This NOR gate will produce B bar. You need product of A bar and B bar. So, AND operation. You need an AND gate here. This A bar will be given to AND gate and B bar is also given to AND gate. This AND gate will produce A bar dot B bar. That means the second bracket. Now there is multiplication operation here. So again there is AND gate. Give this A plus B bar first term of equation to AND gate, and this is second term given to AND gate. So this will produce product of these two brackets, but there is inversion of these two terms also. That means it is actually NAND operation. So put bubble here. So it will become a NAND gate, and then this will produce required Y, right? So in this way we have constructed logic diagram for this equation. We have observed the operations in the equation, and according to the operations we have just placed the gates. Let us move further for the next question. The third question is, prove that following logic circuit is an XOR gate. Now logic circuit is given to you and you have to construct an equation, Boolean expression for this circuit, and then you have to prove that this is performing XOR operation. So how to solve this type of question? Write down the flow of data through the circuit. That means write down the inputs and outputs to each gate and you will get the final output. See here, this is an OR gate and it is receiving A input here and it is receiving B input here at the other terminal. This is OR gate, so it will produce A plus B. This is NAND gate receiving A here and B here, and it will produce NAND operation. That means it will produce A dot B bar. These two inputs are given to this AND gate. So AND gate will produce product of the two inputs. The first input A plus B and the second input A dot B bar. This is Boolean expression for given logic circuit. We have developed an equation. Now let us simplify this equation. Let us convert this equation in the form of XOR operation. So let us solve this. Now let us take the equation y is equal to A plus B into AB bar. This is the equation. Now let us convert this AB bar into the addition form. How will you convert it? Use De Morgan's theorem. Complement of product equals sum of complements. So you can write it like this. The first bracket as it is A plus B, and complement of product equals sum of complements. Sum of complements A bar B bar. So it will be A bar plus B bar. Let us multiply the two brackets. So A bar, then A B bar plus A B bar plus B A bar, then plus B B bar. Now you know the identity, Boolean identity. A dot A bar is 0. So B dot B bar is also 0. So these two terms will get cancelled, and what remains is A B bar plus A bar B, which is nothing but an XOR operation, A XOR B. In this way, we have proved that the given logic equation is an given logic circuit is an XOR gate. What we have done? We have written down the data flow through the gates. We have found the equation for the given logic circuit, and then that equation is simplified into a form which is actually the XOR expression, right? So let us move further. There is one more question here. Write Boolean expression for the following circuit. Now this is again a simple circuit, and to find Boolean expression, what we have to do? We have to write down the data flow through the circuit. So here this is NOT gate receiving A, so this NOT gate will produce A bar. This is one more NOT gate receiving B, it will produce B bar. A bar and B bar are inputs to an XOR gate. So Y will be XOR operation of these two terms. So A bar XOR B bar. This will be the Boolean expression for given logic circuit. There are two more examples given here for practice. Try solving these examples. If you find useful this video, please like it and share it with your friends, and you can subscribe my channel to see more such videos. Thank you.